Welcome to CAST Designer for Gating System Design. In this demonstration, we will introduce the detail approach and process of casting system design for high-pressure die casting, or gating system design in another word. Usually, the main process includes, at first, we need check the geometry feature of the part and the main quality requirement. The second, we will define the parting method and the location of parting plan, also the location of inner gate, center of the piston. Then, we can use the design advisor or other expert system and CAST designer to get the major parameters for the casting system. The last one, also most important, we will use CAST designer to generate the 3D gating system geometry instead of any CAD system. At first, we load in the 3D CAD geometry in a draft design plan. The part geometry is simple, and the draft plan is based on the design experience. Such draft is the basic concept. It will be adjusted and optimized in the later by CAST designer. The draft plan could be done in any CAD system, such as AutoCAD, and import to CAST designer. Of course, it also could be done in CAST designer directly. In this draft design, we set 2 inner gates and 1 major runner. We can adjust the view to have a better looking. Then, we press the Gate System Design button. All the functions of gating system design are integrated in this interface, in different tables. Now, we use the Design Advisor to obtain the key parameters for gating system design. We input the casting mass or volume, also the volume ratio of overflows to casting part, gating system to casting part, as industrial experience. Then, we will select the alloy material and the mold material class. Now, we need to take care of the most important parameter. It is the average wall thickness of casting. As the wall thickness and casting material, the system will calculate the optimized filling time and total inner gate section area automatically. On the other hand, if you know the actual filling time, you also can adjust the wall thickness artificially to match it. Then, we need select the casting machine, whatever cold chamber machine or hot chamber machine are supported by CAST designer. Select machine mainly based on the locking force, which is another function of CAST designer, also the quality requirement and geometry size. After we select the machine, we have to check 2 key values. One is the filling ratio. For cold chamber machine, usually, it should be between 35% to 50%. Also the second speed of casting machine, it should be always has enough allowance for safety. Now, we get the total speed-up ratio of the gating system. It should be divided to the local speed-up ratio to inner gate, gate runner, runner and sprue runner. We need to adjust each local speed-up ratio to match the designed global ratio. For example, in this case, we set the speed-up ratio of gate runner to 2, runner to 1.5 and sprue runner to 6.5, then the global speed-up ratio should be 24.38. This is good enough, compared with the design value 25.4. We also need to find the numbers of the inner gate, gate runner, runner and sprue runner. The table could be adjusted on real time. In this case, the inner gate is 2, gate runner is also 2, and runner is 1, sprue runner is also 1. After this process, we get the final section area of each gating components. Such data can be used in the later to guide the whole gating system design. We use the back-to-front method to design the gating system. It means we design the inner gate at first, then gate runner, runner, and sprue runner will be designed at the end. Now, we begin the inner gate design. At first, we press the Tips button to get online assistant. Based on the average wall thickness of the casting part, we can get the recommend inner gate thickness should be between 1.5 mm to 2.5 mm. Then, we use the inner gate design wizard, it located in the right side of the data table, and pick up the predefined line of the inner gate track, and adjust the width of inner gate, such as 2 for both left and right side in this case. The section numbers of inner gate could be adjusted to 2. After that, we press the Apply button to come back the design main interface. Now, we press the Look 3D button to have a real-time preview of the inner gate. Then we adjust the thickness of the inner gate to 2.3. and also adjust a start angle, and end angle to 25 degree in this case for metal filling. After define all above, we press the Add button, to add inner gate to object lists. Please note, only the data in the object list could be generate the 3D objects, also save to the template file, and use back in the later. In the same method, we can design a second inner gate. The only difference is we set the inner gate thickness to 2.5 to consider the geometry feature of the second one is different. After design all the inner gates, we need check the total section areas, and compare it with the design target. In this example, both the value was quite close, so the design is reasonable. Now, we continue the gate runner and runner design. CAST Designer with a lots of functions. For runner design, this is the most important of GATting system. Some functions are so useful, and advanced, to keep a good design. However, at the beginning, not all the cases need all the functions. In this demonstration, we try to introduce the most useful functions for runner design. We shift to the Runner Design tab, and press the Design Wizard, which located in the right of the data table. The Design Wizard will bring a new windows to simplify the design process. Now, we need to find the flow line of runner, and section area, of start and end section. The area of end section of gate runner should be same as inner gate, which we just defined. Then, we can define the start section area, by the local speed-up ratio, and the end section area. To define the track of runner, we will pick up the predefined feature line, in the draft design. Then, we press the Look 3D button, for a real-time preview. Now, the profile of the gate runner is displayed. The next step is, we wish to control the position of shift point to a new location, and we will introduce another useful function of CAST Designer, how to insert control points. We select the last section from the data list table, and press the right button of mouse, then select Insert Point, and a new window of Insert Point will appear. At first, we define the location of the insert point. To simplify the operation, it is possible to define the percent of the total length of runner. In this case, we set 50%. After we define that, we press the Apply button, then come back the last interface, and press Look 3D again, to check the updated runner. It is still necessary, and possible, to make some fine adjustment of the section parameters of the runner, such as the dimension of height and depth. The "what you see, what you get" work style provides a flexible way for such adjustment. The system has built-in 3-type gate runner: the straight-sided runner, the curved-sided runner, and tangential runner. The user can simply select it directly. In this case, we use the straight-sided runner. It is the first type. The sections numbers of each segments also can be adjusted. After that, we press the Apply button, and come back the runner design interface. We press the Look 3D button, and Look button together, to have a real-time preview, both the 3D geometry, and the section's profile. There are 2 colors of the designed runner. Its meaning is, this runner was combined by 2 segments. In CAST Designer, there is a very important concept: the GATting system was combined by many runners or gate runners. Also, each runner could be combined by many segments, and each segment could be combined by many sections. So, it is possible to design very complex runner and GATting system. We also can set a fillet ratio for the runner, such 30% in this case. Then we can see the runner was filleted. Now, we add the design runner data to the runner object list table. Press the Add button to do that. Then, we can get the information of the section area of the start section and end section of this runner. In the same method and concept, we can define a second runner. Both the above runners are simple. Now, we come to a longer runner or main runner in this case. The main runner is also linked by another two subrunners in the feature line. Let's look how to design it. In fact, the design method is same as before. We open the runner design wizard and define the start section and last section based on the speed up ratio. We also can add more control points for this runner to have a better smooth connection and also easy to control. Now, we will introduce a new concept to make a link of one runner to the main runner automatically. The meaning is, we will add the section area of the defined runner to another runner which on designing. At first, we select link point on the designing runner, then we select the defined runner. All section data of the defined runner will be taken out and set to the displayed windows automatically. After we press the Add button, such data will be plus to the new design runner, such as the section area will be changed. The user is possible to make some small adjustment, if necessary. The reference data will be displayed in the side always, to guide the design. No limitation of how many subrunners could be linked to a main runner. After the above definition, we press the Apply button, and come back to the last interface. We can find the section area of the runner has been updated. In the same method, we add another control point to the main runner at first, then we join the second gate runner to the main runner. Press the Look 3D button to have a real-time preview for any modification, then we can press the Apply button, and come back the runner design interface. This runner was combined by 4 segments. You are also possible to make some adjustment of each segments and sections, if necessary. Now, the whole runner system has been designed. It includes 2 gate runners and 1 major runner. Since all data was fully parametric in Cast Designer, so all data could be adjusted in any time. We start the sprue runner design now, and shift the interface to sprue runner table. Cast Designer supports cold chamber, hot chamber, and non-sprue runner design. In this demonstration, the casting machine is cold chamber machine. Now, we define the center location coordinate of the piston. It could be defined by the snap functions in Cast Designer, also the sprue runner direction. Then some other parameters for the sprue runner. We must take care of the local speed-up ratio of sprue runner, which we defined before. Press the Look 3D button, can preview the designed sprue runner in real time, and adjust it by free. After we define the runner, we can press the Add button to set the data to object list table, where the start section area and end section area will be displayed. Cast Designer also support multi-sprue runner design. Now, the whole gating system has been designed. Press the Save button to save the design data to a gating system file. It could be reload and use back in the later. Then we press the Apply All button to generate the 3D CAD compounds for the gating system. The last section of this demonstration is overflow design. As the geometry feature of the part, we have defined the location of the overflow in the draft. So, we just simply follow such design to define the overflow, one by one. In fact, it is also possible to run a CPI analysis with gating system at first. After the simulation, you can put the overflows based on the filling result in the second round. We open the overflow design window. The interface is similar to the gating system design. We need to find the location position of overflow, direction, and detailed dimensions. 3 types overflow has built in Cast Designer: the rectangular overflow, orbicular overflow, and wedge overflow. To simplify the operation and save time for user, Cast Designer has set a series of overflows in the system as template for each overflow type. So, the user can select the most close overflow and press it, then redefine the location and orientation, also adjust some dimensions. Then the overflow has defined. We select the center point, orientation, and adjust a few parameters for overflow, then press the Add button to add the overflow to the object list. It can support multi-plans design. We found the second overflow is the symmetry of the first one. So we put the mouse on the data set of the first overflow, and press right button, use mirror to define the center point, and normal direction, for a new overflow. In a similar way, we can design the third overflow, fourth overflow. We also find the fifth overflow could be the translation of the fourth overflow, so we can use the method as above to generate it. Cast Designer also support complex shape overflow, like non-standard overflow design. Now, all the overflows has been designed well. Please save the overflow data, and generate to 3D CAD compounds. Until now, the full gating system, and overflow system has been designed. Please save the data, and check your result in Global. So, this is the main topic of this demonstration. With more understanding of Cast Designer, you will like it more. Goodbye.